Let's learn about the properties of logarithms. We're going to evaluate logarithms. We will start with reviewing exponent rules. We'll discover 3 properties of logarithms, and then we will expand and condense using those properties. Let's get ready. You're going to need your notebook and pencil. I don't want you to use a calculator. Here's the warm-up. So if I have log base 2 of 1/2, well, we can think of 1/2 as 2 to the negative 1. So remember what a logarithm is helping you find. It's helping you find the exponent. So the answer here is negative 1. We can do logarithms and get negative answers. And number 2, we have log base 2 of 1. So if I think of this as x and I rewrite it with exponent form, 2 to the x equals 1. The only way I'm going to get 1 is if x is 0. So a few ways of thinking about logs. Let's review our exponent rules. All of these have the same base. I called the base a. The rules apply only when you have the same base. So when you're multiplying with the same base, here in the first example we're multiplying, then we're going to add our exponents. When you're dividing and have the same base, then you're going to end up subtracting your exponents. And whenever you have a power raised to another power, you're going to multiply those exponents. It's going to be really important because these are going to transfer over to our logarithm rules. So let's just investigate first. We're going to try to think of, after looking at a pattern, what we can do to add logs. So if I first just evaluate log base 2 of 8, so 2 to the what is 8? Well, that would be 3. Log base 2 of 2, anything that has the same base in itself, is 1. So this is going to be 1, and this answer overall is 4. We just solved logarithms. Let's try the next one. Log base 2 of 16, 2 to the what is 16, so that's going to be 4. Log base 2 of 4 is 2, and we have 6. Next problem, log base 3 of 27. 3 to the what is 27? That's going to be 3. Log base 3 of 3, same number, so that's going to be 1. And I have another 4. Log base 3 of 1. 3 to the what is 1? 0. Plus log base 3 of 9. 3 to the what is 9, 2, and we get 2. All right, well, I don't really see a pattern other than they all came out to be integers. So let's look at the first one again, and notice how they both have log base 2. Can we come up with a problem that stays log base 2 and equals 4? Because this one equals 4. Well, if I think about exponent form, that would be 2 to the 4th. Let's call this x equals x. So that means x would be 16. So now I have log base 2 of 16 equals 4. Can you see any relationship with 8, 2, and 16? Okay, I'm going to let you think about that. Let's try this one. We have log base 2 again. This time, we'll call that x. We want it to equal 6. So 2 to the 6 equals x. And that would be 64. So we have log base 2 of 64 equals 6, because 2 to the 6 equals 64. What's the relationship between 16, 4, and 64? Let's try it here. Log base 3 of some number x, and we want this one to equal 4. We switch to exponent form. 3 to the 4 equals x, so x is 81. What's the relationship between 27, 3, and 81? Log base 3 of x equals 2. So 3 to the 2 equals x. X is 9. What's the relationship between 1 and 9? Hopefully you can see it by the time we did the problem. When you are adding logs with the same base, you can just multiply those two numbers together, and that will help you move along in a problem, solve a problem. Let's look at what happens with subtraction. We're going to evaluate again. So log base 2 of 16 is 4, minus log base 2 of 8 is 3, for an answer of 1. Log base 2 of 32 is 5, minus log base 2 of 4 is 2, for 3. Log base 3 of 81 is 4, minus log base 3 of 9 is 2, equals 2. And log base 3 of 3 is 1, minus log base 3 of 27 is 3, for -2, your overall answers can be negative answers. The only thing, we're not taking logs of negatives. That's just where we can't have the negatives. So let's go ahead and think like we thought before. So we have log base 2 of some unknown number x is going to equal 1. So x is going to equal 2 to the 1, or 2. And we want to think of the relationship between 16, 8, and 2. In our next example, log base 2 of x is going to equal 3. So now x is going to equal 2 to the 3, or 8. What's the relationship between 32, 4, and 8? Log base 3 of some unknown number x equals 2. Well, x equals 3 squared, which is 9. The relationship between 81, 9, and 9. And log base 3 of some unknown number x is -2. Oh, x is 3 to the -2. X is 1/9. What's the relationship between 3 and 27? Dun, dun, dun. When you subtract, when you have the same bases, you are going to divide the number. So subtraction goes to division, just like our exponent rules. That's what happened there. One thing really important, when you're subtracting a log minus a log, and you have a log like this, it's log of a fraction. Don't put this full fraction bar here. It's not a log divided by a log. That should not be there. That should not be there. It's a log of a fraction. So really important that you make sure you write it the same way, because the way that was written before means something different. All right, one more rule to investigate. Let's see what happens here. So log base 2 of 2 to the 3s. Well, I could say 2 to the 3 is 8, and log base 2 of 8 is 3. Log base 2 to the 4 is 16. 2 to the what is 16, so that's going to be 4. This one, I don't know 3 to the 5 off my head, but if I go back and look at a pattern, 3, 3, 4, 4, 5, maybe 5. The other thing that has to happen is they have to have the same base and numbers. Those are both 2s. Those are both 3s. So I'm guessing my last one is going to be 18. Why this happens? So when you have the exponent, you can bring it out in front and it becomes multiplication like that. So if I have log base 2 of 2 to the 3, and I was just converting it to 8. But if I think about moving this number in front, then it becomes 3 log base 2 of 2. Log base 2 of 2 is 1. And I have 3 times 1, which is 3. So you can think of this as 1, and you move the 3 out in front. So there are our log words all put together. And we are going to use them to condense and expand. When you take this left side, which is bigger, and you condense it to one log word with multiplication. So when you go from left to right, you are condensing. Again, with the subtraction, make sure it's the subtraction of the fraction and the bar doesn't go under the word log. And then if you had an exponent, like if this was up here, you move it up there and that is fully condensed. Going the other direction is expanding. So if I gave you the right side, then you have to pull everything apart. So let's look at condensing for a minute. One log word if you are fully condensed. Expanding. When you're going from right to left, you're going to pull everything apart. Numbers must be prime. So a number like 20, that has to be broken down into 2, 2, and 5 and spread it out. Make it as big as you can. Numbers, 8x, those have to be separated. That's 8 times x. It's going to get separated with an addition sign. And moving your exponents, when you expand, your exponents come out in front to become multiplication. All right, let's expand. Here we have, why is the whole thing moving? All right, here we go. We have log base 8 of 2. Division means subtraction, so minus log base 8 of 3. And if you want, you could replace this with 1/3 as well. In the 6, you might think, what can I do with the 6? But you do want to make them both prime, so you're going to break that up. That's multiplication, so it becomes log 2 plus log 3. Notice there is no base written, so it is an assumed 10. And for number 3, you have to separate the number from the variable, and you have to move the 3 to be out in front, only for the x, not for the 7. So this becomes log base 2 of 7 plus 3 log base 2 of x. Let's condense. So I see some addition, so that's going to become multiplication. So this becomes log, keep the same base, 8 of 6 times x. This 2 goes up to be an exponent, y squared. In example 5, this is the whole numerator. This is all addition, which becomes multiplication. The subtraction sign means division. So I'm going to do log 2 times 3 is 6. This 3 becomes an exponent. And then just under the 6, not the whole log word, I'm going to divide by y squared. Let's apply the properties and see how this works. So this looks a little scary, but if I think on the left, I see subtraction. On the right, I see division. So x is just going to be 3. This one gets a little more challenging. Find the numerical value of the logarithm expression given these. So I have log a. It doesn't mean that a is that. It means log a is that. So the first thing we want to do is we want to expand this as far as we can. So I have the b and the c that I want to separate, and I want to move their exponents. And then this is a division bar, so we'll switch over to subtraction. So I'm going to do 4 log b plus 5 log c minus a to the 7/3, because that radical, the index, goes in the denominator. So that 7/3 is going to come out in front of log a. Log b is negative 6. 4 times negative 6. Log c is 2. Oops. And then times negative 3. So here we have negative 24 plus 10 plus 21 for an answer of 7. And we just solved that challenging problem. And our last problem we're going to solve, and this is going to be a little sneak ahead to when we do actually solve. So I want to condense on the left side. So I'm going to condense that to log base 2 of a distributive property. So I need a little bit of parentheses there, and that equals 4. So I went from 2 log words to 1 log word. Whenever you have 1 log word, you can now switch over to exponential form and rewrite it. So I start with my base of 2, and then I go to my answer, which will become my exponent. So I have 2 to the 4 equals, I'm going to distribute this, equals that. So I get x squared minus 6x. And then I'm going to subtract the 16 over. And I have something that is factorable, so I'm going to factor it. I'm going to set each equal to 0 and solve. And then you do have to check your answers. Don't forget, some of them might be extraneous. I'm a little curious about the negative, so I'm going to check. You cannot take the log of a negative number. So we do have to reject that one. And let's try the 8 log base 2 of 8 plus log base 2 of 8 minus 6 equals 4. We have 3 plus 1 equals 4. It works. We solved a log problem. With those 3 properties of logs, you can expand and condense and solve. And you'll be able to do everything with those 3 properties. Nice job.